This is a pretty special time. The OFGC has worked pretty hard to put this together, and we're going to do it on a weekly basis, and this is the first one. I'm Woody Lane. Those of you who know me, I'm a livestock nutritionist and forage specialist, and I'm from Roseburg, and also am the president of OFGC. Our guest today is Dennis Hancock. Dennis is the director of the USDA Dairy Forage Lab in Madison, Wisconsin. He just took that position in January. Before that, for many years, he was at the University of Georgia as the state extension specialist, and I've known Dennis for a long time. One of the most respected forage people in the country, without any question at all, and knows a lot about how to explain things and really knows his stuff. And we're really pleased to have him. Dennis earned his PhD out of University of Kentucky, and has a wide knowledge. So we're very happy that he's on. We also want to thank. This couldn't happen without someone behind the scenes pushing buttons, and Connie Carr from Salem, who is on the board of OFGC, and also her regular job was with Oregon Tilth, has been very instrumental in even making this happen. She's our IT god today, and we're really glad that she's there. In any case, we'll get started. A couple of ground rules. You can see us. We can't really see you. We don't. There's not that many, pictures, but we see you. We see each other on the screen, and you can see us. What we're going to do is, this is a discussion. This is a back and forth thing. Dennis and I will talk a bit, and we'll talk a little bit. But this is also an open thing. You can provide questions to us through, there's a chat box, or there's a little thing at the bottom of your screen that says chat. There's also one called Q&A. You can use either one. Q&A, I think, is a better one, if that can work. And you can type in some topic or, that you want to hear about, and possibly we can open it up. That depends on the situation. We might be able to open up a microphone. But in any case, use that. So this is a multi-way conversation. So with that, let's get started. Dennis, we're really glad that you're on. You're coming into us from Madison, I think Madison, Wisconsin, are you?
Yep. Yeah, I'm coming in from my my home office at the moment, as is everyone else.
Well, you want to explain a little bit who you are, and I just gave the most briefest thing, but what you're doing now, and then we can go from there.
Yeah, so my role is as the center director for the U.S. Dairy Forage Research Center. We have 3 research units. We have the Dairy Forage Research Unit, and then we also have the Cell Wall Biology and Utilization Research Unit, and then we also have the Environmentally Integrated Dairy Management Research Unit. Those 3 units are scattered across Wisconsin. We have 2 of those units on campus at the University of Wisconsin in Madison, and then the Environmentally Integrated Dairy Management Research Unit is located in Marshfield, more central Wisconsin, and that's an area where we have a lot of research ongoing into the environmental impacts of dairy production. So our cell wall unit, for example, does a lot of work and a lot of research in the basics of nutrient digestion, fiber digestion, protein digestion, some of the basic types of research, but also a lot of applied research. We have a lot of animal trials where we're feeding different rations and developing more refined recommendations for ration balancing and development. We also have a grass and clover breeding program. So we have perennial grasses and principally red clover, although we have some other legumes that are being bred at our research center as well. In total, we have 22 scientists, and each of those scientists has a research technician, at least one. Sometimes it's multiple, depending on the grants and whatnot that they have. So as I've come on board and we've gone into our current max telework posture, we get daily attendance reports, and there's actually 101 people that report through our program. So we have a lot of actions going on at any one point in time.
When you were in Georgia, of course, it's a completely different role. You were the extension specialist for forages, and you gave hundreds of talks.
Oh yeah, yeah, quite a bit of a different role. For the previous 20 years, before starting at the center here in January of this year, for the previous 20 years, I was an extension member of the extension world. For 13 of those, I was as an extension specialist at the University of Georgia. Prior to that, I was 4 years as an associate, extension associate at the University of Kentucky. And prior to that, I started my extension career as a county extension agent. So left the extension world behind, but not totally. Once you're in extension, you're always in extension. It's kind of a fraternity or a sorority type of mentality. But I still bring that very practical, on-farm, real-world type of approach to the research that we do, and that really informs and shapes the research that we do here at the center. Prior to that, I grew up on a beef cattle farm in western Kentucky as well. We had a cow-calf operation, and my uncles had the row crop operation. We also owned a lime and fertilizer spreading business. So I have been eating and drinking agriculture since I was knee-high to a grasshopper, as they say.
Well, and thank you. Again, we'll repeat, if people have questions or comments, or just what about this or that, by all means, type them into the chat or the Q&A box, and try the Q&A boxes, because we're not quite sure how that all works. So please do add stuff. I know that alfalfa is a really big deal. That at that lab, and a lot of research is going into it for good reason. Of course, around the country, it's the #1 forage that's bought and sold, and it's used so much in the dairy rations. But you're also doing work in some other things as well. I mean, red clover being one, but and on the west side here, red clover is actually probably more common than alfalfa is, because of our pHs and wet soils and stuff. What other species is the lab involved with?
Well, a good number of them. I'll give props to Heathcliff Rade, who is our legume breeder here at the Dairy Forage Research Center. He principally, as I mentioned, breeds red clover and has a great line of clovers in development. I've always, and I've shared this with you before, Woody, I always have considered red clover to be the most underutilized legume species that we use in the United States. It's easy to get established, really grazes well if you're doing good grazing management, and very, very productive and very tolerant of a much wider range of soil conditions than, say, alfalfa. But we also have a fair effort going on vetch, hairy vetch principally for cover crop production. That is one legume species that has some tremendous potential as a cover crop legume. There are other legume species that are being looked at as well, but switching gears to the perennial grasses, we have Dr. Mike Kassler, who has been a long time grass breeder for us, and prior to that, actually, he was at the University of Wisconsin on the faculty there. But he's been working on several different things, including looking at things like orchard grass and so forth. But meadow fescue is one that he really has made a name for himself on, and that's a species that is coming from Kentucky and most recently Georgia. Meadow fescue was something that really wasn't all that applicable down to our area, but in the upper Midwest and across the northern parts of the United States, meadow fescue, I think, has got a real fit. He's also been working a lot with native warm season grasses, not only for the bioenergy aspect, but also incorporating that into the dairy platform as well. There's some real merit to having some of those warm season perennials in diets. It's high digestible fiber, and a perennial system like that has some real major advantages in the landscape for our dairy systems, and I think there's some real roles for that too, particularly in fields that are kind of on the margins and so forth. So large effort in many of those, and then we work very closely with. We don't have any alfalfa breeding in Madison, but in our sister location in Minneapolis, Minnesota, at St. Paul, our ARS brethren there actually have a very strong alfalfa breeding program. One of the few public alfalfa breeding programs left in the country. There's the one at the University of Georgia. There's one at UC Davis, and a smattering across the other parts of the U.S. But largely, those are the few that are left of the public breeding for alfalfa.
I know that of course, the lab there is focusing a lot of its resources, and you're trying to get more resources going to our alfalfa for good reason. A lot of people here, though, are listening. They're on the west side, and a couple of things that have you come across much issues at all in the red clover world? Of course, a lot of people are a little hesitant to even plant it because of the potential for phytoestrogens. Yeah. Have you run in? I mean, I personally have come across some of that, but also there's no real commercial lab that you can actually find out what's going on. So how do you deal with it?
That's a great question, Woody. And I think, the issues with phytoestrogens are one in which it's significant. I don't want to be dismissive of it, but I do think probably much like bloat, the issue of bloat, I think that's an issue that is a significant issue, but oftentimes there's more worry about it than is necessary. I think there's some management aspects that can be put into place for both of those topics to make that less of an issue. Yes, there have been documented cases of pure red clover with sheep, particularly ewes, who are having some issues with reproductive success as a result of that. Certainly that can be a concern. A couple of years ago, I wrote an article on phytoestrogens in clover. I believe that came out in the Progressive Forage Grower magazine. I encourage the listeners to check that out. But there's actually a fair amount of potential for those phytoestrogens as well. Now, particularly in the southeast, where there's a lot of tall fescue that's grown, there's some work from some of my colleagues at the ARS research facility in Lexington, Kentucky, the Food Animal Production Research Unit, where they are finding that phytoestrogens in red clover may actually offset the endophyte in tall fescue, the alkaloids that are being produced by that endophyte, causing blood vessel, the consequence of those alkaloids is that blood vessels constrict. Well, the feeding of some of those phytoestrogens actually cause them to expand and to relax. Those phytoestrogens,
and it actually was very, very fascinating.
Yeah, it's a really interesting natural phenomenon, and it's also worth pointing out that some of the growth hormones that we, growth promotants that we give to livestock, for example, things like Rowgrow or the other one escapes me at the moment. But anyway, those actually have estradiol, which right. is a mimic of those same phytoestrogens. So it has some growth promoting characteristics to it beyond just that relaxant, that vasoconstricting versus vasorelaxant characteristic.
So the Dairy Forage Lab isn't looking at taking red clover and trying to stick it in a steer's ear.
No pellets of red clover going in the ear. Yeah. We'd rather them take it in the old-fashioned way. It's a lot cheaper that way.
Yeah, okay. I won't make any further jokes on that one. We got a couple of Q&As. Some folks are figuring out how to use it. There's Here's one. If you fertilize this time of year, how long until livestock can be grazed on those fields without harm from nitrates? And
Yeah, I got to put my extension hat on and say it depends. Um,
okay,
so, you know, nitrates accumulate when we have a reduction in the growth rate. Okay, so nitrates, the way nitrogen absorption occurs in the plant is the plant basically draws up as much nitrate as it can possibly absorb at one time. And then it begins to grow and dilute it out and turning it into protein and so forth. So as those pastures are emerging in the spring and they're just beginning to emerge, when we fertilize with lots of nitrogen there and we get proper growth conditions for excellent growth, then it should be really rapidly decreasing that nitrate concentration. It also depends, though, on what form of nitrogen you're fertilizing with. So ammonium nitrate, for example, which is ammonium and nitrate, so you right there have a salt that is readily absorbed by the plant. That one would probably have the greatest risk of any of the nitrogen sources that we have. Even though it's the best, it's Cadillac of nitrogen sources. Conversely, urea is actually, chemically speaking, an organic compound. It has to be broken down before it has to be converted from urea to ammonium. And in some cases, what's going to happen is you get ammonia that comes off in that process, and you lose some of that as ammonia gas. So that step by step process actually slows down the absorption of that nitrogen up. So it's rare that we're going to have issues with nitrates immediately after putting on urea. Anything can happen though. The other question I often get is, is there a risk of having those animals out there when we are fertilizing? In general, we would recommend that we wait at least a week after fertilizing before putting those animals out. Although that's really more just to cover our basis and to minimize the risk. I know many producers who don't necessarily abide by that, and their philosophy is just don't hit them with the truck, as they're spreading it. And they've rolled the dice and fared okay. But again, it comes down to whether or not there are conditions that are limiting the growth. It has to have been taken up, but then conditions limiting its growth. So, for example, when we go into a situation, as I understand you all are in a bit of a drought at the moment.
Yeah.
If, let's say, back in the end of March, 1st of April, you had some, enough moisture there to initiate a little bit of growth. You got the itch that only the tractor seat can scratch, and you went out in the field and put in some nitrogen at that point, and it was able to take it up, but then because of the drought has been unable to grow and thin that out, then yes, there are huge risks that are associated with that. So be sure and test your crop before you actually start grazing it.
Sometimes it's not just, let's say a drought is a classic thing, but very, very long stretches of very heavily cloudy weather combined with a very available nitrogen coming up the soil, you've got that condition where it's kind of like a drought in that sense, but the plant slows down in growth, but it continues to bring nitrogen into the plant.
Yeah, absolutely. Anything that slows down its growth can result in that situation. I've seen that with cloud cover or, extended periods of time with cloud cover, cool conditions, that things warm up really well, and then all of a sudden we're back down into cool temperatures in the spring of the year that are extended, and that slows down growth enough that we can end up with some significantly high nitrate levels.
Well, this is actually important as we're going into the summer now, and there's going to be some irrigation, and people will be planting some C4 warm season grasses like sorghum Sudan grass and millet, both of which have, if someone picks up a goes online and looks this up, they will see that, as Dr. Google will say, oh, there's nitrate problems with these plants. And yeah, under some conditions, but those plants can pick up an awful lot of nitrogen in a hurry, but they also grow really fast. But a drought can duplicate those situations.
Yeah, and drought can do that. There are also issues with you know, how you're grazing it too. You know, there was an article a few, maybe a year or two back that Mary Junowski wrote. I believe Mary was the one. She and Matt Poore from NC State. Mary's at Iowa State, and Matt is her major professor from her PhD degree at NC State. And they wrote an article on, is the risk of nitrate toxicity overblown? And I find a lot of truth in what they found there. Is that their point is that, you know, in grazing, rarely do we have issues with nitrates. It's usually with conserved forage of some sort, whether that be hay or silage or baleage. Not to say that it can't happen, and there are certainly instances where you can have nitrate toxicity in a grazing setting, but it also depends on how deep into that sward you're grazing. And a classic example is summer annuals. So summer annuals, if you graze summer annuals, if you've ever grazed them, you know that the animals generally are going to defoliate all the leaves first. And if they're starving to death, then they'll start after the stem as well. You know, they tend not to raise those stems down much closer than about 6 or 8 inches unless they are just running out of feed. And that's where your nitrates are going to be most highly concentrated, is in the lower part of those stems. Whether that's a summer annual or a cool season perennial is going to be the same way. Incidentally, a few years ago, we had a, this is one of those days where I lost sleep over this one. I get a call from one of our better beef cattle producers, and the NRCS state grazing land specialist had been out to visit his farm, and they'd taken some samples, and they'd sent it to the lab at the University of Georgia. And so I get this frantic call from first the producer, and then immediately after that from the NRCS grazing land specialist. And they had been working on grazing some cover crops. And so they had a cover crop mix of some summer annual grasses and I believe it was cowpea and sun hemp. Those cowpea, sun hemp, and then pearl millet and sorghum sudan grass was the mixture.
Sun hemp, of course, is a legume.
Is a legume, yeah, and cowpea is a legume as well. And it turns out the sun hemp wasn't growing very well in that particular situation, but the cowpea was doing quite well. They took a gram sample from the field where they had clipped an area and processed that and submitted the whole sample. It was a mixture of all of those. Sent it into the lab, and the results came back something like 26,000 parts per million. So immediately bells and whistles start going off in everybody's head. We're about to kill some cows, you know. And he sent me the results and said, what do I do? I said, well, get those animals out of there immediately. Do not pass go. Do not collect $200. Get those cows out immediately until we can really figure out what's going on here. Well, you know, this producer is very, let's put it this way, he's set in his ways, okay? So he said, you know, those cows don't look so bad. I'm just going to leave them out there and see how things go. And these were not cows, by the way. These were steers that they were grazing on those.
So he wasn't worried about reproductive problems.
Yeah, I wasn't necessarily worried about reproductive issues. And he said, well, let me just roll the dice because those animals are slicked off. They look great. Let's see what happens. 2 weeks go by and nothing at all happens. And in the meantime, what I'd asked the state grazing land specialist to do is to go out and pull a sample and then separate it out into the botanical composition. So you had pearl millet, sorghum sudan grass, and the cowpea and the sun hemp, And so what, let's see what actually is high and what's causing that. Because my money was on is probably the sorghum Sudan grass or the pearl millet that's the highest. Is probably they got a bunch of stem in their sample, and that's probably why it's so high. And that, from all practical purposes, they may not be grazing on it. Well, it turns out that that neither one of those things were true. Actually, it turns out that the highest level of nitrates wasn't in the pearl millet, wasn't in the sorghum Sudan grass. It was in the leaves of the cowpea. The cowpea leaves had 36,000 parts per million nitrates in it. And I was absolutely floored by this. And it resonated with me because our point of reference there is anything above 4,500 parts per million, we say is capable of killing animals. But yet those animals were doing just fine grazing that. And as well as I do, they were preferentially grazing that cowpea at that high nitrate level. Long story short, he ended up not having problems. So I think, this issue with nitrates may be, I'm not going to say it's overblown, because I still think that there are times where we have major issues, but I would submit that I think we still don't know all the answers as to what's going on there. It's a much more complex story than just a simple concentration.
Well, those lab tests probably showed how much soluble sugars and starches were in those plants, and that could have made a very big difference relative to using the nitrate in the rumen. So
absolutely. But in contrast, though, if they had made hay off of that, those levels are going to be much lower, and as a result, the nitrate levels may be more active, so to speak, or more.
Well, if you fed hay like that, you would have a much smaller transport expense to market.
Yeah, sure. You would have a burial expense, most likely.
Just as a matter of point, Shelby Philly, the extension agent down in our area, had mentioned in a chat thing here is Circun Ates lab who's a forage person in faculty member at Oregon State. In his lab, he has nitrate test strips. He has nitrate test strips that you can use to screen nitrate levels from forages. So they're like, here it is right now. You get something back in a few minutes. So people can keep that in mind, because they can go to the extension agent, make a contact like that, and if they have an issue.
Yeah, that's absolutely the case, and we have a number of state extension specialists have the recipe for how to do that around. And those are good for a semi-quantitative assessment. So a spot examination in the field, that's great. And if you're trying to balance the ration to minimize it, you probably want to go ahead for a further detailed analysis. But for sure, it is one that can be done in the field as kind of a it is or it isn't type of thing. And greetings, by the way, to my traveling buddy there, Shelby. She and I traveled across New Zealand together a few years ago.
We have another question having to do with, we have another question relative to red clover. Gordon Jones down in Southern Oregon has asking, what are the breeding objectives for red clover? Are they just yield, forage quality, persistence, disease resistance? And by the way, red clover grown in Western Oregon classically is known as a biennial, but we normally get 3 years up to 4 years on a straight stand of red clover. So because of the climate here.
Yeah. So the answer to that is yes. All of those things we're looking at. Heathcliff is interested in all of those aspects, and obviously the brass ring is one that has all of those characteristics in one variety. Principally, though, yield is probably still the most dominant thing. Grazing persistence. I know there is some work done in many of his trials. He screens for persistence, and looking at disease resistance and rating those for disease tolerance is also a big part of that. So yeah, all of those objectives are part of that breeding program. Some are naturally going to excel in certain areas and maybe lack in one or two of those characteristics. So you have to take the good with the bad sometimes. But yeah, that all of those are in consideration.
Well, here's something I know you've had experience with when you're in Georgia. We're going into, of course, the summer here, and people will be planting, well, typically sorghum Sudan grass if they're going to put an annual in for irrigation. And there's a couple of characteristics that are now in sorghum Sudan grass that are great that could be usable. However, two species, and one of which you just mentioned, cowpea, and the other one, sun hemp, both of which are warm season legumes. Do you think that they could have during the summer here, just like sorghum Sudan grass, could they be legumes that we could have a future here, could be actually grown with the grass and have a much more complete, higher level of nutrition, of crude protein in these? What do you think about those two species?
Well, I have to say with a caveat that, to my knowledge of Oregon's climate, although I've been out to Oregon a few times and thoroughly enjoy my visits out there, and I appreciate Woody's invitation to visit a few farms out there. I hesitate at saying, exactly how it's going to do, because I just am not as thoroughly familiar with the climate there. However, I will say, though, I feel like that there's a growing body of evidence for both of those species, and probably even more so for sun hemp. But cowpea is probably my favorite of those two. It's one that after it is grazed, it's more upright and erect and initially, but once it's grazed, as long as you leave a few buds from it to grow back from it, it tends to go viney and trail more, and covers the ground and spreads out wherever it has an opportunity much better than sun hemp, in my opinion. We've grown both. We actually haven't done any grazing trials with both, but I have a lot of experience with it in grazing. The cowpea, actually, we have done some grazing work with, and it works remarkably well. Sun hemp, I think, for small ruminants probably is a really good choice as well. But both of those have their fit. The one thing I will say about sun hemp is that by itself, it is a fast grower. Within about 60 to 90 days, you can get a huge amount of dry matter off of that thing. So a lot of growers are making baleage off of it, and I think that's a good for a short-term crop that's high in nitrogen, high in protein. That's a good option. I would hesitate to say, though, that it's really all that economically viable. It's a fairly expensive crop to grow for what you've got in it, or at least it has been. Times have changed, and seed prices might have gone down now. I will also pause and say that some states, it is actually illegal to grow sun hemp in it, not because of the name hemp, but because it's in the Crotalaria family. And in some states, anything with the genus Crotalaria is not capable of being sown. For a while, at least, Mississippi was that way. I'm not sure if that's the case in Oregon or not, but just be aware that in some states that is a limitation.
I don't think it is. Maybe someone can answer who's online. But in some states, chicory was a noxious weed that could not be grown either. And here it is, one of a main forage around the country, but yet struggling with certain state regulations.
Yeah. The various definitions of what is noxious across this country is kind of odd. In some areas in the southeast, Sericea lespedeza was the poor man's alfalfa. It was treated as gold down there, but yet if you were in Kansas and you mentioned Sericea lespedeza, you had to spit after you said it because it's such a dirty word.
Well, there are. Well, I'm not sure. The seed of. I was just thinking that the potential of mixing some of these summer and annual, warm season legumes in a stand, with the seed of of our typical warm season grasses, not to grow in monoculture, but just have this mass of forage growing, either for grazing or maybe for cutting for baleage or whatever. It's kind of a new concept here of using warm season legumes.
Well, it is, and I would be remiss though if I didn't point out that the research on those mixtures are not always clear as to whether it is more productive, whether from a metric of biomass or animal performance. In fact, there are many studies that would suggest, I would actually say the majority of those studies that I've reviewed have showed that there's really not a positive from a standpoint of animal production. If you look at grazing gains or grazing productivity, although I'm not dismissing that idea or that concept of planting multiple species. I think it builds robustness into the system. But just because you're mixing several species together does not necessarily mean that you're going to be more profitable or, using sustainable calling that more sustainable. It's not necessarily the case.
Well, it's funny you're saying that because some of the discussions that are going on right now in the forage groups are exactly, well, what about this unusual seed mix? And you probably know of various types of seed mixtures around the country, but basically having 8 or 10 or 15 different species, and if it grows, it grows. And if it covers the ground and gives a lot of yield and it's green and healthy and nutritious, that's not a bad thing. And if the resulting pasture is more robust and the soil health is improved because of the various types of root systems that are developed in mycorrhizae. So that's an active discussion. There's a lot unknown about that right now, and it's certainly a lot harder to do any science on it.
Definitely so. And if you think about it from a scientific reductionist perspective, where you're trying to reduce all the factors, you have multiple species. Well, which one of those species actually caused the effect, or is it a synergistic effect? And right now, it's hard to say there even is a positive effect. So yeah, and every situation, every farm may be a little bit different as well. So there are very few absolutes.
One of the Q&As we got back, Jerry Hall from Grassland, Oregon. The crotalaria is a noxious weed in Alabama, Arkansas, Georgia, and Mississippi, but not here. We're good in Oregon.
Yeah, very good.
Good to know. And there's a list of, you can find noxious weeds at the USDA. There's lists of them by state in various places online.
By the way, put in a plug for my organization. They did a lot of work with Sun Hemp and Auburn, Alabama, with ARS research facility there 20, 30 years ago. So there's folks been talking about this for a long time. It seems like Sun Hemp is the newest thing to emerge, but it's been around for a while. It's just now there's some legit seed availability out there. So.
Well, I also must say that for those who don't know, Sun Hemp is not hemp. Those are completely different species, and it could be that because so much discussion has been on hemp, and obviously all the acres has gone in, all the money's gone in. The word sun hemp has been thrown around as well, and people are now more aware of it, even though it has virtually nothing to do with the hemp plant that the hemp plant that we're grazing for other things. So they're completely different.
None at all.
I was at a talk that you gave at the American Forage and Grasslands Council meeting. Oh, well, one of the questions that came in earlier was, and this has to do with the research that's going on right now that you're doing, or it's done in the labs there. A lot of the stuff that's going on, say with alfalfa, is using alfalfa in dairy rations and TMRs, and looking at all sorts of nutritional characteristics as well as the agronomic characteristics. So alfalfa being alfalfa. But then there's the whole set of grazing, well, it's a minority, but grazing dairies, grass-based dairies that are primarily grazing. Alfalfa might be one field or not. Is there much work done in your lab concerning that would be directly applicable to those dairies and by extension, other grazing operations? or is most of the stuff that you're doing, that the researchers are doing in your lab, tend to be things that for confinement operations where you have much better control of the diet? What do you think?
Well, I'll be honest that the majority of the work that we do is focused on those in which a ration is being developed for those animals and being fed, not so much at grazing. That's not to say that there's not been grazing work done at our research center over the years, nor does that indicate that that's going to be the future either. Um, for example, recent history is Jeff Brink, who some of you know had been a long-term ARS researcher at the Dairy Forage Research Center. And Jeff has done a number of grazing trials here at our research center. And most recently, some work was done at our Marshfield location in central Wisconsin. And actually, the plans are, and this is just between us and the fence post, and no one else is listening in, right?
Oh, no, not at all.
Yeah. But we are in the discussion right now. I have a position description that has been written for a grazing systems researcher that would be based at Marshfield. Principally in the context of heifer development, although we also hope to do some lactating cow work trials on that too. But I would also say that in addition to that work and future work, it's not that there has been a wholesale setting it off to one side. There has been a significant effort of trying to plug in. And I principally will point folks to both Dr. Kassler and Dr. Ryday, our two, our grass and our legume breeder, because a lot of what their work is focused in is providing the best possible pasture species for those who are grazing. And legitimately, if we think about nationwide, there are estimates that are somewhere around 20% on average of our dairy herds are pasture-based. Now,
when you say pasture-based, it's where most of the nutritional component is coming off pastures.
Yeah, from 50% or more of the dry matter intake is coming from pasture in an annual period. And of course, our organic dairies also have a requirement now for grazing too. So there's a significant need for that information, and that's something that is not lost on us. We do feel strongly that we have had a history of that, but I would submit, I would suggest that we are going more in that direction probably we ever have been. I come from a grazing background, so I do things a lot from that lens. As you well know, Woody, when I was in Georgia, we had a huge increase in the number of pasture-based areas there, and certainly right now, that's a platform that looks quite appealing. They're certainly not losing as much money as some of the larger dairies are. So, but that all being said, we are the U.S. Dairy Forage Research Center, which means we are for all dairies of all stripes, of all sizes, all shapes, all forms. And we legitimately do go to pains to make sure that what we're working on is as broadly applicable as possible. So, whether that's working on alfalfa, which as we get down into the southwestern states, alfalfa is a huge component of the dairy rations there. Whether that's corn silage, which we do a fair amount of work on that here as well, particularly for those of us here in the Midwest, where that's a principal part of their dairy rations there too. But also from a pasture standpoint too, we have some considerations on all that too.
Well, there's, as USDA, I mean, you have a very broad responsibility, and the dairy industry has only a relatively small percentage that are dependent on grazing, even though it tends to be more profitable or they're losing less money now. It's the nature of the different type of model involved. One question that did come in is, at your research station, is there any research on different types of electric fences?
Yeah, no, we haven't. We don't do any work with electric fencing at all. Although I appreciate and really agree that that's an issue that there needs to be some research done on that. At least some engineering work, at least in engineering evaluations, if you will. I would like to see at some point some sort of testing program like they do with the tractor testing that is done in some of the Central Plains states. But no, unfortunately, we don't have the capability or the skill set, if you will, the engineers. We actually don't currently have any engineers among our scientists at the moment. So.
Last time I was in New Zealand, I took, of course, lots and lots of pictures of fences. After a few weeks driving around almost 2,000 miles, I don't think I saw a single H brace the whole time. Different approach.
Yeah, very different approach. Very different approach, particularly on South Island down there. It's very different.
I was in a meeting that you were giving a talk at a Forage and Grasslands Council meeting, and you were describing various using of clovers, or in the conversation you had mentioned that the amount of nitrogen fixed by clovers is directly correlated to the amount of dry matter above ground by those clovers. In other words, those low varieties are fixing in the field less nitrogen, much less nitrogen than one that would be an upstanding higher yield thing. Can you expand on that a little bit?
Yeah, in fact, I may be able to try to find that presentation. I don't remember if I can or not, but as I'm talking, maybe I can try to find that. There is a direct relationship there between the growth of the alfalfa or the clover species, and I think I have found it here. Hold on just a second. Because I think this graph that, if I find the one that I think I found, this graph may put this in better perspective.
Yeah, because of course, it's not a new concept of putting clovers or other legumes into pastures, but different varieties grow. I mean, the characteristics are, some of them are kind of low. Well, and there's a lot of white clover varieties out there, and some of them are very low, and the total yield of white clover may be quite low. So here you go.
For sure. Especially, let me see if I can get this into full screen here. Yeah, can you see that okay?
Yeah, I can. Everyone else can raise their hand.
Yeah, hopefully you can see that well. But let me just kind of walk through this, and I apologize. I'm looking at a side screen here, so I'm not looking directly at the camera. But for example, you can see white clover there, and that's a classic example, right? You have some Dutch white clover that's growing out in your pasture, and it's only about 4 inches tall at best. How much nitrogen is that actually contributing? Well, the true answer is not much. The amount of biological nitrogen fixation is directly related to the amount of forage yield that is produced. And so you can see here, for example, white clover, if you've got a variety out there that is producing 4.5 tons of dry matter per year, you're producing close to 300 pounds of nitrogen. Same thing for red clover. There's a direct relationship, and alfalfa as well. So, and this is a common example with producers who are worried about controlling weeds when they have a little bit of clover out there. Well, if you go to look at those pastures, oftentimes it's that little white Dutch clover, and it might be, at best, on a good day, it might be producing 1,000 pounds or 1,500 pounds of dry matter per acre. So you're really not getting much benefit from that little small amount of clover anyway.
Not from the pasture. I mean, nutrition is nice, but for the animal, but the amount of nitrogen fixation is actually not nearly as much. It's not negligible, but it's not very much.
Yeah, and I would even submit that if you've got that kind of clover out there, it probably isn't really contributing a huge amount to the nutritional balance. It might be helpful a little bit. Don't get me wrong, but 1,000 pounds of it to the acre is relative to, and I'm talking an annual yield, by the way, is minuscule compared to a grass that might produce even 4 tons each year. So.
Yeah, and there are pastures around that do that. Now, is this graph that you have up here, this graphic that you have up there, is this basically a good argument to plant kudzu?
Well, here's the thing about kudzu, of course, is you don't have kudzu in Oregon?
I'm not familiar with any kudzu. I mean, we'd be happy to send you some gorse, but I'm not sure about kudzu.
Yeah, you can keep that, and I'm sure our southeastern brethren would be happy to send you some kudzu as well. But problem with kudzu is that if you graze it a couple times, it's gone. It's not very grazing tolerant. And that's the best way actually to get rid of it. Many of the municipalities in Georgia, for example, they would hire herds of folks that would bring in herds of animals, and usually goats. They would have someone who would bring in a group of goats to do vegetation control, and that's the best way of getting rid of kudzu. It's not very grazing tolerant at all, so it's got to be persistent, to really have this effect. So.
But it does put nitrogen in the soil.
It does produce a lot of nitrogen, and actually, when you look at the yield though of kudzu, it's not as impressive as it looks like. There's a lot of it, but it isn't a lot of dry matter by comparison.
Well, one of the things that is going on now within the seed industry and for forages is the striving finally to look at is striving to look at the digestibility of fiber as being a component of, well, it's obviously important in nutrition across the board, whether it's a TMR or whether the animals are grazing it. And is the fiber digestibility? I know Dave Combs is just across the road there from you. Was one of the early people driving for that. Is the USDA lab dealing with that in a way that at this point can be extrapolated to the field?
Yeah, definitely so. I mean, that has been part of our history for practically the entire 40 years that our research center has been in existence. And by the way, we do celebrate our 40th anniversary this year. In July of this year, we will celebrate the 40th year of actually having animals on site, and then next year we will celebrate 40 years of our building being there. But yeah, Dave Combs is a classic example, even though he was at the University of Wisconsin. He and Dave Mertens at our research center in Madison, as well as a number of other folks over the years, have been looking at that. And now Mary Beth Hall is one who is continuing that mantle. And I should say that it's a group effort within our research center. We have basically the whole cell wall biology and utilization research unit looking at various components and parts of that, from fiber digestibility to protein and tannin content, and a whole complex of considerations on digestibility of that forage is being considered. So we continue to do that work. Interesting, a lot of the work that we are looking at now is looking at those interactions between protein digestion, protein utilization, and starch utilization, as well as fiber. And those three actually interact in a variety of complex ways, and trying to tease all of that out is what our research team is really trying to do.
And what's happening inside the rumen.
That's inside the rumen. And now I would say though too, we've also been looking at, and Dave Combs was very good about doing this, looking at beyond just the rumen. There's a lot that happens downstream, if you will, from the rumen. And I constantly will kind of joke with our dairy nutritionists that, yeah, they have degrees in ruminant nutrition, but there's more to ruminant nutrition than just what happens in the rumen. There's a lot that happens further down.
Dave was very total tract, true digestibility. which is
Yeah.
the big thing is, what goes in one end and then measured out the other end and stuff like that, which is kind of interesting because if you think about it, this is a modern thing that people are really finally looking at, which is pretty much the same as what we call TDN.
Right. Right. It's
100
yeah.
years ago. It just
Concept.
what goes around comes around sometimes, but that is the concept.
Yep. More or less, that's the concept. Yeah. In a nutshell, it's a little more nuanced, but yeah, that ultimately the concept is of what goes into that animal, how much energy can we derive, as well as other nutrients, can we derive from that feed.
So, in terms of the digestibility of the fiber and other things, are you working, or does the lab work in any way directly with any of the seed companies?
Yes and no. I guess I would say that there are a variety of efforts that we have ongoing to interact with a number of seed companies. We don't necessarily do trial work or verification of work that they're doing. That's kind of not our purview. We look for novel concepts and take things in additional directions. So, if a seed company comes to us and they want to evaluate a particular variety or something like that, that's not our business. Our approach is really to help explain how things work and to develop new ways and new workarounds to try to improve fiber digestion or protein digestion, as well as other positive impacts in the whole ecosystem. We haven't really talked too much about that, but one of the key aspects of what we look at is not just the nutrition aspect, but also what's happening in the whole landscape. So that's a key aspect too.
Well, your landscape around the lab is all concrete, so I'm not quite sure how that works.
Well, not around our farm out at the Prairie du Sac Research Farm. We have 2,000 acres there. That's a very diverse landscape.
Yeah, well, I used to work across the street from where that lab is.
Yeah.
People know that the USDA lab is right there on the campus of the University of Wisconsin in Madison. Yeah. So it's part of the campus, although it's a separate institution.
Yeah.
We're going to be ending in another minute or so. Dennis, would you like to, any philosophy that you want to share, or where we might be going as a forage industry, or certainly grazing? We're talking about Oregon here, but you have a national view as well.
Well, we have a lot of ideas about further direction, and one of the first things I did was I challenged all of my scientists to outline and send to me what they felt like the U.S. Dairy Forage Research Center should be known for in 10 years' time. And true to form, as scientists go, I got more than 10 items from everyone. We have a lot of work ongoing, and what strikes me, and the whole reason that I am in Wisconsin, is because I want to work with dairy producers to make a more efficient and more sustainable, in the true sense of that word, dairy production platform. And we're excited to be able to do that. I guess in summary of that, it goes back to something that Chad Hale I saw on earlier. He kids me about this every now and then. My signature on my email used to say a quote from Thomas Edison that was something to the effect that there's a better way to do it, find it. And that's kind of my philosophy, is there's always a better way of doing what we're doing. And I mean that in a true sense of the word. There's better from an economic and efficiency standpoint, as well as from a sustainability standpoint.
Do you see, well, there's no way of knowing if federal money is going to increase or decrease. So you know what you can hope for, and whatever happens, happens. Does the Dairy Forage Lab work intimately with other USDA sites around the country, or is it more or less running on its own for most part?
Yeah, I mean, we are fairly autonomous, but I will say this: we have a very strong relationship with a variety of ARS research facilities and universities. By the way, we have a number of research collaborations with universities and companies around the U.S. and some across the world too. By the way, so yes, I see us operating in a larger industry-wide approach. We have a lot of things that we can bring into the conversation because we are such a big research center and cover so many bases. But yeah, we have a lot of collaboration with our ARIS research colleagues around the country.
Well, Dennis, it's been a real pleasure the hour goes by quickly, to say the least. This is our inaugural session, #1 session for the Oregon Forage and Grasslands Council Forages e-forum, which is going to be every week. We're going to end now. Of course, we didn't figure this out how to actually end this thing. We're kind of playing it by ear, especially on this first one. Dennis Hancock, of course, is the director now of the USDA experiments, USDA Dairy Forage Lab in Madison, Wisconsin. Formerly was the extension forage specialist for the University of Georgia. And we're really delighted, Dennis, you were able to join us today. We've had a lot of questions. We're going to examine how this all worked on committee meetings afterwards. This is being put on by the Oregon Forage and Grasslands Council, and we're hoping we're getting more members down the road. We're offering things, and so the idea is that this is a good organization to be part of because this is some of the work that it's doing. So with that, we're going to sign off. And Dennis, thank you for your time. And remember, next week, same time, same place. You can come to the same place. And you do have to register for each one separately, by the way. We're going to have Tom Maxwell, who is a lecturer, which is like an assistant professor at the university, at Lincoln University in Christchurch, or just south of Christchurch on South Island in New Zealand. Tom will join us live. And so we'll have a perspective that yeah, it'll be upside down, I know, but nonetheless, it's going to be something that I know Tom and a very good person, and I hope you all can join us join us next week at noon. So again, Dennis, thank you for spending the time, and it's been a pleasure to see you again. And
thank you. Appreciate the invitation.
Down the road. All right, thank you everyone for coming, and we'll see you next week.
Thank you.
Bye now.
Bye.